Cosmic glass found only in Australia reveals an asteroid impact, while the future of space travel may rely on salty ice, and space-based solar panels could help the net zero transition. This is a wrap of the past 6 Talkin Science Daily Bites. The Deep Extragalactic Visible Legacy Survey, DEVILS, has released its initial data and a series of recent publications explaining how a galaxy's location in the universe can significantly influence its evolution. The survey combines data from a wide range of international and space-based telescopes to investigate various aspects of astrophysics by analysing hundreds of thousands of galaxies. Project lead Associate Professor Luke Davies from the University of Western Australia node of ICRA said the work represented the culmination of a decade's worth of planning, observations and data analysis, offering a new level of detail in our understanding of galaxies in the distant universe. The DEVILS survey is unique in that it is the first of its kind to explore the detailed aspects of the distant universe. It focuses on galaxies that existed up to 5 billion years ago and examines how these galaxies have changed to the present day. From this new approach, Associate Professor Davies and his team have found that where a galaxy lives strongly influences its shape, size and growth rate in the distant universe. This data will allow researchers to identify the number of stars in a galaxy, understand ongoing star formation and analyse their visual appearance, shapes and structures. They can then compare these properties between galaxies in the present day universe to galaxies that existed around 5 billion years ago, and determine how galaxies are changing in time. The DEVILS paper was published in the monthly notices of the Royal Astronomical Society. Martian mudstones from the Jezero crater contain features that improve our understanding of chemical processes on Mars, according to new findings from NASA's Perseverance rover, published in Nature. The Jezero crater was selected as the landing site for NASA's Perseverance rover due to its geological diversity and evidence of past water activity. The rover has explored igneous and sedimentary terrains, including the Bright Angel Formation, a collection of mudstones exposed in Neretiva Valles. These rocks are of particular interest because they contain carbon matter and mineral assemblages that may have formed under habitable conditions, but this is yet to be confirmed. Joel Horowitz and colleagues conducted a detailed analysis of the Bright Angel Formation and identified tiny nodules and specks enriched in iron phosphate and iron sulfide. These features are associated with organic carbon and appear to have formed after sediment deposition under low temperature conditions. Further analyses revealed that these minerals are concentrated in specific zones and are not evenly distributed throughout the mudstone. The presence of these minerals, textures and carbon features in a sedimentary context could support their classification as potential biosignatures. Salty ice can generate an electric charge 1,000 times greater than regular ice when strained, according to research published in Nature Materials. Further research could investigate how this phenomenon could enable sustainable energy generation at low temperatures where salt and ice mix, with implications for ice geologies. For example, in glaciers or moons in the outer solar system, such as Europa or Enceladus. Now, 10% of the Earth's surface is covered by ice, which can generate electricity upon bending, but its potential power remains untapped. This phenomenon, known as the flexoelectric effect, depends on the material, and pure water ice has failed to generate a substantial enough current to power small electrical devices, with a current from pure ice of about 1 to 10 nanocoulombs per metre. I'm saying that completely wrong. Google it. The authors note that further research is needed to determine how this energy generation could power electronics. However, these findings suggest that environmentally sustainable and cheap energy harvesting and sensing devices could be implemented in cold locations. Similarly, the results may have implications for natural systems where salt ions and ice mix, such as in glaciers or outer solar system moons. That exploding star has given researchers a rare chance to find out what the inside of old stars looks like, according to an international study. And usually when a star explodes in a supernova, the internal layers get mixed up, making it hard to determine its structure. However, in 2021, a star called 2021 YFJ exploded after having already lost most of its outer layers, giving the researchers a chance to see what it looked like on the inside. They found a thick, massive silicon and sulfur-rich shell, which was expelled by the star shortly before the supernova explosion. However, they also detected helium, which was surprising, as it was assumed that this lighter element would have been lost during earlier stages of the supernova. Writing in an accompanying News and Views article, Anya Nugent and Peter Nugent say that the discovery provides direct confirmation that stars have the theoretically predicted shell structure all the way down to their silicon and sulfur-rich layers. They add that the findings uncover mysteries about how massive stars end their lives. Well, it may sound futuristic, but international researchers say space-based solar panels could allow us to harvest energy from the sun almost every moment of the day. The first of the two projects, named the innovative Heliostat Swarm, is in early development, but is the most likely to be able to continuously capture solar energy. The second, named the Mature Planar Array, is much closer to being ready, but will only capture solar energy around 60% of the time. Still a big step up from solar panels based on Earth. Overall, the model estimated that the Heliostat design would reduce total system costs by 7 to 15%, offset up to 80% of wind and solar, and reduce battery usage by over 70%. The authors say the current designs are not yet cost effective, but hope the two systems can be honed to help with our future net zero needs. The researchers note that many technological breakthroughs are needed before space-based solar power can be implemented. In particular, large-scale testing of wireless transmission is essential, and advancements are needed to enable the devices to be robotically assembled while in orbit. To build a large-scale quantum computer that works, scientists and engineers need to overcome the spontaneous errors that quantum bits, or qubits, create as they operate. Now, for the first time, quantum scientists at the Quantum Control Laboratory at the University of Sydney Nano Institute have demonstrated a type of quantum logic gate that drastically reduces the number of physical qubits needed for this operation. To do this, they built an entangling logic gate on a single atom using an error-correcting code nicknamed the Rosetta stone of quantum computing. It earns that name because it translates smooth, continuous quantum oscillations into clean, digital-like discrete states, making errors easier to spot and fix, and importantly, allowing a highly compact way to encode logical qubits. A logic gate is an information switch that allows computers, quantum and classical, to be programmable to perform logical operations. Quantum logic gates use the entanglement of qubits to produce a completely different sort of operational system to that used in classical computing, underpinning the great promise of quantum computers. First author Vasily Matsos is a PhD student in the School of Physics in Sydney Nano. He said, effectively, we store two error-correctable logical qubits in a single trapped ion and demonstrate entanglement between them. What Mr. Matsos did is entangle two quantum vibrations of a single atom. The trapped atom vibrates in 3 dimensions. Movement in each dimension is described by quantum mechanics, and each is considered a quantum state. By entangling 2 of these quantum states, realised as qubits, Mr. Matsos created a logic gate using just a single atom, a milestone in quantum technology. This result massively reduces the quantum hardware required to create these logic gates, which allow quantum machines to be programmed. I had to restart the overlay, there's a lot of words in there, and I think I follow all of that. More science and space news with an Aussie flair in 2026, plus the occasional science fiction podcast. Like, follow and subscribe for more. Membership helps me do more, so get on board and help out for the cost of a cup of coffee a month. thetrek.zone/support for details.